Today's lecture and live session is about the array reduce function, or sometimes you'll see this like prototype reduce, which is kind of like the more formal way to talk about methods, that is functions that are available on all arrays. And the array reduce is really, really one of the most powerful methods because it allows us to do almost anything we need to do to manipulate an array and to do anything we like on an array just using this one function. So basically, if we go to MDN and search for array methods, you'll find that the array structure has, I believe, the most of the methods available to it. I don't think there's any other JavaScript structure that has so many methods. You have map, you have pop, you have push, you have reduce, shift. So all these methods that are found under the array section on MDN, I'm not even sure how many we have here. So all these are methods or functions that we can run on an array, and they can do pretty much anything you'd want to be done on an array, like reverse the array, the order, sort it based on some condition, splice or slice, that is split, the array into different parts, find something, push, like something at the end of the array, pop, like remove something from the end of the array, join arrays together. So they're really powerful. I highly recommend that you take a look at all these methods to know what kind of like a power JavaScript gives you. But I believe by far the most powerful one is the one that we're going to see today. It's the reduce, which is also one of the hardest methods to get your head around. But basically, it's so powerful because if we can use reduce, and we can pretty much do anything all these other methods are doing. So we can replicate the each of these methods just with this one reduce method. We can replicate map, we can replicate sort, we can replicate like filter, we can replicate I don't know, slice. So we can do pretty much everything that most of the other methods do. That's why it's really powerful. And also it allows us to, as the name suggests, to reduce an array into something completely different. So we can take in an array of values and reduce it to like a Boolean, a string, another array, an object, almost anything, any kind of value you can actually use in JavaScript. So that's why reduce is really powerful. Let me start by going through a few examples. I'm going to start with an array first that is going to be filled with some very simple values. It will be an array of these simple objects, and they're going to have an ID, a name. I'm going to just stick with a single letter and an age. I'm going to put 3 more entries and change the names and the age. So suppose this is kind of like our small database. We have like an array of 4 user objects. They each have their own unique ID, which is something that you'll always see in data, especially in databases. Every entry will have some kind of like unique identifier. And then we have some properties, in this case, the name and the age of the user. So this will be our array, and we're going to deal with this array in various ways. So we can use, we will use reduce to do a couple of things. Okay, so first I'm going to show you like the array filter method to see how array filter works. And then we're going to use reduce to actually do exactly the same thing, but using reduce. So with filter, let's say I want to get users above 30. Okay, I want to create a variable and I want to filter all the users that are below 30 or 30 and below. So I just want to filter this array and grab only these two entries, which is something that you need to do a lot of all the times. Just filter an array and get a certain part of the array based on some condition, based on some requirement. In this case, we want to pick just these entries, or we maybe want to pick everyone that's above 30 or above 40 and so forth. So with filter, you start by with the array, you call the filter function, and then you pass a callback function. You pass a function in here. You can either use this syntax like an anonymous arrow function, and you immediately define it inside these parentheses, or maybe you can define it outside. So let's say filter by age. So maybe you define it in here, and then you pass in the function name. This is a much kind of a cleaner, I would say, syntax. It's easier to read and it's easier like to maintain. So use anything you like. If it's a small function, maybe you can put it in here. Otherwise, you can just define a function elsewhere. So what this is going to do is going to execute this function. Filter will go through every user's entry, every array entry, this one, then this one, then this one, then this one. So the length of the array in this case is 4, right? So if I console log users length, I'll get 4. So filter will always execute this function 4 times. How many elements? 4. We're going to see this function executed 4 times. How many elements? 2. 2 times. And we can see it here. I can console log, let's say, the name of the function. And you can see that it's executed 4 times. So filter will always execute the function for every single array element. If I remove 2 elements and the array length goes down to 2, I will see this console log 2 times, and so forth. So we get to execute this function 4 times. And the filter function works in this way. If we want the specific entry, as we've gone through these entries and we execute the function for every entry's value is inside this parameter, is automatically found in this parameter. So user, this is the first entry. Sorry, this is the second. This is the first entry. This is the second, the third, and the fourth. So every single entry will be available through this user parameter, or you can put parentheses around it to make it a little bit easier to read. And you can do pretty much anything you want with the console, the user value. So you have these entries, which are objects, and you can say .age and just see the user age. Okay, so run through the array, call this function, have the value available to us through this user, and then pick, any property you like and do anything. Of course, you can change it. You can, I don't know, say user age something. You can assign like a value. And the filter works by returning a Boolean. So we have to return a Boolean, either true or false. If we return true, the element that we're currently iterating through, either this one, this one, this one, this one, this will be included in the resulting filtered array. So if the return statement of the callback function returns true, the element will be included in this array. So if this callback returns true in all cases, then the result array will contain every single element. So you will see here, let me just comment this, that the resulting array contains every single object. Okay, because the function went through its user, and the answer to the question, should I include this entry to the new array? So that's kind of like basically the question that we're asking here. So true, false is the answer to the question, should I include this entry in the new filtered array? That's the responsibility, that's the role of this function. Do something, and based on some condition, answer this question. Should this particular entry 1, entry 2, entry 3, entry 4, whatever, be included in this new array that will be returned by the filter function? If you have true, every single value will be included. If you return false, then the answer is no, do not include it. So there will be no entries. Okay. Now, returning true or false in this way, it doesn't really make sense because returning true will have exactly the same array. Every single element will be included in the new filtered array. So it's identical. So perhaps we don't need that. And false will return an empty array, which also isn't very useful to us. But if we return a Boolean based on some condition, for example, based on the condition of whether the user's age is above 30, then this condition will return true in these cases. So in only these cases, user.age will be above 30. And so this will be true in these last two cases, and this will be false in these two cases. So false here, and true here, and true here. Okay, so we go through each entry, and based on this condition, we return a Boolean. And you can also check this. You can store, which is a nice practice. You can store the Boolean, this Boolean, this logical comparison in a variable. So is above 30. So I will store this in a variable, and then just use the variable name here. This is much also nicer to read, and I can console log the condition now. As I'm using a variable, I can also see the value of this expression. So we see it's false, false, true, true. This is how you check your condition. For example, if for some reason I wanted like to have all the users above 30, including those that are 30 years old, I would be missing, this guy here. So I can console log the user age. I can console log the result of this expression, and I would see where I'm making, a false assumption. So in here, when the age is 30, this is false, which means I have to fix this and change the condition to something like above or equal to 30, which means I'm going to include 30. So now this condition is console logged. I can see whether it's true or false. I can also compare it with the actual user age. So now my assumption is correct. If I also want this age to be included, 30, and I can see the result, which is an array of users that are of age 30 plus. So this will be true. And generally, this is how filter works. Okay, this is like really, really useful method. We use it a lot. We constantly work with arrays in software. Every single thing that you see online is an array. Your posts, your tweets, your emails, your YouTube videos, like everything is an array, right? When we open up a website or we open up like an application, we get a list of things: news, posts, videos, whatever. They come in the form of lists of arrays, and filtering those lists is like really, really crucial. I want to filter my emails based on some condition, based on the emails that I have read or the ones that I haven't read. Filter emails by subject, or filter a song list or a music playlist based on the artist. So array manipulation is really almost a daily task. So we have the filter, and this is one way to do it by using, like a definition like this. A much shorter way to do this would be to just define the the callback function in here without using like the more, let's say, compressed version. So I can define the arrow function in here directly. I don't have like to store it in a variable or declare it elsewhere. And I can omit the curly brackets, which means there's an implicit return statement here. If you don't put the brackets on an arrow function, you have a return statement in here implicitly. It's you don't have to put it, but it's JavaScript automatically returns this part. So you can think of like an invisible return statement here. And basically, we kind of like reduce our, let's say, sorry for the pun, our code into just a single line. I believe this is better for everyone because it's much more readable. It's easier to debug. We can console log, and we can add some comments. Whereas this one is, if it works, is okay. But if I have to debug it and I have to console log, I have to add like curly brackets and add more lines and maybe do something with a code and try to fix it. So this is like the built-in filter. Okay, I will just comment this console log. Now we're going to do exactly the same thing, like filter by age, using the reduce function, just to learn the reduce function, and then we'll try a couple of variations, like maybe filter based on the name or the ID. We'll see. Okay, so how do we go about doing exactly the same thing by using reduce? I'm going to start by saying users above 30, same logic. I will name it reduced because we're going to be using reduce function instead of filter. Okay. Now, reduce, whenever you start using reduce, there are a couple of things that you have to do every single time you're using reduce, regardless of what kind of like reducement or reducing you're going to do, like reducing an array into a number, reducing an array into a filter array, or whatever. The first thing you have to think about is what is going to be your target. What is going to be your end product? So reduce is about taking an array, starting with an array, and reducing it to another value. So this can be another array, this can be a Boolean, this can be a string, this can be an object. So the first thing you have to do is think about what is this reduce going to produce. right? So you're starting always with the input is always an array. A reduce is an array method, and the output can be anything we can use in JavaScript. So pick any value in JavaScript, array, object, set, function, boolean, string, undefined, whatever. You have to think about what is going to be your end product. If we're going to filter an array, this means that we need an array. So in this case, if we're going to filter, the input is going to be an array. That's something we cannot change. And the output is going to be an array. The only difference is that the output array is going to be a limited version of the original array, kind of like a filtered version. So first you have to think about the output, what kind of type you're going to end up with. The next is to come up with the very basic, like, let's say, skeleton of the function that we place inside the reduce. So the reduce function accepts a callback function. So you have to define a function. It can be, it can either be an arrow function, or it can be a function definition. So you pick whatever thing you like. I will stick with arrow functions because they are kind of like reducing a little bit some of the characters that we need. So you start by placing a function, and that's the first argument. So reduce has this callback function, and then it has what we call the accumulator, which is basically the output. Okay, so the accumulator, which means it means something that accumulates. That's something that accumulates values, accumulates things. That it's also the output. Okay, so the second argument to the reduce function, this is the first argument, is the output, or in JavaScript terminology, it's called the accumulator. Okay. Now, if you find some of these terms a little bit intimidating, or maybe they're, it's a word that you first come across in English, what I recommend that you always do is you find the definition of the English word. So you type define accumulator, like in search engine, and it says it's the thing that accumulates. Okay. And it will give you some definition, or maybe translate it into your native language. Okay. Maybe accumulate, just to be clear what accumulate. We find some definition. And it means to gather, to pile up. Okay. Maybe it's even better. So, or increase gradually in quantities. So it's something that gathers, accumulates, aggregates, stuff, and you come up with, it's kind of like a bucket or a thing that piles up some things. So if the term is a little bit confusing, or I don't know, it's even a word you come across for the first time, first try to find the English definition. It will make much more sense. So the accumulator is the value that will pick up some of the array values, and we will come up with an output. In this case, the second argument is going to be an array. Okay, so once you know that you will be outputting, the accumulator is going to be, the end product is going to be an array, you put it as the second argument. So you put it after the comma. So this is where the arrow function starts, the first argument. This is where it ends, and then comma and the array, the accumulator. If the accumulator, the output, were going to be like I don't know, maybe a number. If this is going to be a number, then you put something like a number here. Let's say 0, or some other number. You have to also pick what is going to be the initial value. Sometimes it's 0, sometimes it's something different. In our case, we're going to be accumulating into an array because this is the filtered array that we want to get back, an array of these two elements. And then in here, you have, like, I would suggest that you start by adding these 4 arguments that the reduce function has. You don't have to always use all 4 of them, but it's nice to start by always defining them in here. So the first one is the accumulator, and we'll see how this works. So the first argument is always the accumulator. Now, because the accumulator is like a big word, I'm going to shrink it down to ACC, so AC for short. The second one is the value. This is the actual user, for example, in this case. The third one is the index, and the fourth one is the array, short for R. Okay, let's see how this works. So first of all, I made a typo here. Once again, the reduce is going to go through the array on the left side, and for every single entry is going to execute this callback function. Okay, the same logic applies. Go through the array, and what is the length of this array? It's 4. So execute this function 4 times. If this array has just 2 entries, it's going to execute this function 2 times. If the array is empty, it's going to execute 0 times, right? So if you try to filter or reduce or to run most of these array functions for an empty array, you will get no code executed. Okay. Okay. Let me put this back. And we can always test this visually to see whether we're going to see some kind of like a console log, 4 times. So we see this string 4 times, which makes sense because this function was executed 4 times, and we know that this is going to be executed. Okay, 4 times. Now, the different values, the different entries of the array will be available on the second argument, the value. Okay, that's why I named this value. So if I console log value, we will see 4 console logs with the object entries. The first one, the second one, the third one, and the fourth one. Okay, so the second argument contains the actual value. When this function gets executed, this is where the first, the second, the third, the fourth, and so forth entries will be included. And since these entries are objects, we can pick like the property aids. So we can say dot aids or dot name or the ID and the aids and the name. So name is A, value of the ID is 1, 2, 3, 4, and the aids. So we have everything we need, either as an object or as a specific object property. Now, what do we want to do in this case? We want to filter and just get the values that have aids over 30. Now, let's check what comes out of this reduce function. Okay, remember the filter function gave us back a filtered array, an array that contained just the entries that we filtered, like the 2 entries. Let's see what comes out of this users above 30 reduce. We get undefined, okay, which is strange. Okay, why? What did happen? So we went through these values, and we ended up getting back an undefined in here. Why did we get undefined? Because at the end of this loop, after reduce goes through the full cycle, like goes through the 4 elements and gives us has to give us back a value. What it returns is basically what this function returns. So if we return undefined, which is the default return statement, if we forget to put a return in a function, we get return undefined. So the reduce function returns the it's about the return statement here. If I change this to, like, I don't know, a number, we will get 42. Now, what we want to do is we want to reduce an input array into an output array, which means we want to return some kind of an array. Okay. In this case, an empty array, but of course we want to fill it with values. And really, if you remember, the whole point is to return the accumulator. Okay. So the value that will accumulate will pile up some values. And this value here is the initial value of the accumulator. So this is the initial. So we start and we say, okay, this bucket that is going to accumulate values is going to start as an empty array. And then every time we go through this function, we'll have access to this accumulator through the first argument. So if I put here ACC, you'll see that we have the initial value here once, twice, 4, 5 times, and so forth. And we get the value. So the accumulator starts with the initial value. And then, of course, we have to return it so that each iteration passes the accumulator to the next iteration, so that we end up at the end of this cycle that we get the final accumulator. Okay, so we start with an initial value of the accumulator. We always return the accumulator on every callback function so that we don't end up with undefined. And now our role is to basically do something with the accumulator in each iteration. So that's the whole purpose of reduce. Start with an initial value for an accumulator, do something with the accumulator on every single call of this callback function, and then return it so that at the end of this reduce lifecycle, we end up with some kind of like a different value, not an empty array. Okay, so let's try some silly things. Let me push. Remember, the accumulator starts as an array. We return it on every iteration, so it's always going to be an array. So let me try and push the value age into this array accumulator. So let's see what happens. Let me see if I can draw here. Okay, yes, I can draw. So we started with the initial value. We defined the initial accumulator value here. Okay, so we see it in here. Now, during the first iteration, we start with an empty array, and we push into that array, that empty array, the value of the first, the value age of the first user, which is 20. So we start with an empty array, and then we push 20 into the empty array, and we return. Okay, so we start with an empty array. This is an empty array. We push, which becomes 20, and then we return it. So we return the array with 20 inside it. So the first iteration ends, and now the next iteration, so then the second time this function gets executed, AC will be the returned value from the previous iteration, which is array20. So this is being picked up by the next call of this function. What are we doing in the second iteration? We start with array20, with an array that contains 20. We push value.age, so this becomes 20, 30, and then we return, which means we pass this value onto the next iteration, the next function call. So the next time we console log acc here, it's going to be this guy here. And this continues, so we start with this accumulator, we put 40 here, right? We return. It becomes available in the next iteration, we push 50. So 20, 30, 40, 50. We return. And this last return value, okay, the last time this is going to be executed, this function is going to be executed, the fourth time, the return value is going to end up being the value of this variable. So this is basically how reduce works. Okay, so just to give you a basic boilerplate, now that we kind of like saw this example, let me go through a much simpler example. I'll start with a list. So numbers. And let's say we want to reduce this to something. So we start and we say const filtered nums reduce. So let's say we decide that we want the end product, the output of this reduce to be an array. We define the function and we say this is going to be an array. Okay, so start like this, a simple empty arrow function at first, and then you set the initial value. Okay, the next step is to add the 4 arguments to the reduce function. So accumulator, value, index, and array. We're going to see these 2 arguments in a bit. So then just fill in the 4 arguments that the reduce callback function accepts. The next step, so you're going to do this once, okay, not in like this, is to, which is important, to return the accumulator. Always do this, okay? Because we want to always return to the accumulator so that it becomes available on the next steps and finally being put into this variable. So this is crucial. So this is basically how you should start every single reduce. Define the callback function, put these 4 arguments, return the accumulator, pick an initial value for the array, and then you start thinking about exactly what you're going to be doing with the accumulator. Okay, in each iteration. And this is how you should start, and this is how we're going to start every single example that we're going to see here. Okay, so you can copy this. Basically, I can also share this code now, and I will send it. So this is how you should you can also copy paste, but I would highly recommend that you type this every single time you try an example. You should start every reduce example. Okay, the only thing that will be different in this boilerplate is the accumulator value. In this case, I'm using an array, but this can be, as you will see later on, a different value. It can be an object, it can be like a set, it can be like a number, it can be a Boolean. This will be changing depending on what the end output of the reduce function will be. So let's compare these two. You see we have the same structure here, a callback function with these 4 arguments. We return the accumulator, and then we're doing something more in this case. But this is how you should start whenever you're about to reduce an array into something. Now, the reduce function is one of the trickiest and one of the most difficult, like to get your head around. So this is why I'm giving you like this tip, like have this as a starting point and write it down like manually. Don't copy and paste. It's going to stick with you if you type it. And the more examples you go through, we'll try to go through as many examples as we can. The better it will, the more it will make sense. Okay. So the more examples, the more comfortable you will become. But in the beginning, it's a little bit confusing. It's one of the hardest array methods that exist. Okay, let me just finish up this reducer to just have the end result that we're looking for, and then we're going to take a break and get back with some more examples. So in this case, we are like accumulating values, right? So this is basically the accumulation. Like we start with this, and our initial bucket here, our initial value accumulates values on every iteration, and we end up with this. So this is kind of like the accumulation product, the piling up, right? We start with an empty bucket, and then we put the age value, and then we end up with this full array. That's the whole point. But instead of having an array with all the values, all the age values, we want to end up with specific values, right? We want to end up with values that are 30 or above 30. So this means that we don't need to unconditionally push the value.age on every iteration, like push 20, push 30, push 40, push 50. Okay, so we have to put this in a condition. So if value.age is over 30 or 30, only then and only then push this into the array. So now this accumulator, let's say, modification happens only under this condition. And this is how we end up with exactly the same array that we got from the filter. Okay. So run this 4 times. We can see the console log here, and end up with an accumulator that contains only the values above 30. So almost close to the filter. So this is pretty close to what we are doing here, but we get some more arguments here. We get an initial value, the accumulator, we have to return. So it's a lot more code and a little bit more things to wrap our heads around. But in the end, you will see that this is really powerful, and you can do pretty much anything you want with the arrays. And sometimes you want to do something with an array and there's no available method. There are quite a lot of methods, but maybe you want to do something a little bit fancier or something more advanced. And this is where you're going to use the reduce function to do some advanced, let's say, filtering or accumulation of values or some interesting things that we're going to see after the break. So here's our filter using the reduce method. I highly recommend that you console log the accumulator, the value, and after the break we will see also index and array to see what these values do, just to get like a feeling of how this works. You will see, each iteration in here. You will see the different values, what the accumulator is value is on each iteration, what's the value, the second argument's value is on each iteration. And also it makes sense that since we are reducing users, so the values that are inside the users are concerning users, we can rename the value to something that relates to the particular value. So instead of value, which is very generic, I'm going to use user, like a singular. Okay, same result, just a better naming for the second argument. Okay, so usually what we do is we have a plural users and the value is singular user. Profiles, profile. Cars, car. Tweets, tweet. Posts, post, and so forth. So we use a singular form. We have the filter reduce. So we replicated the filter method using reduce. Let's go one step further and do some other manipulation. Let me go through the same users list, and let's say filtered users. So once again, I'm going to use reduce. So I'm going to start with the basic boilerplate. So users reduce. Then I'm going to define the callback function. The initial accumulator value, I'm going to have an array, and then put accumulator user, or I will stick with value for now just to get to know, index array, return accumulator. So this is like basic boilerplate, the callback with the 4 arguments, returning the accumulator and picking an initial accumulator value. And then just console logging the final array, which is of course an empty array. We start with an empty array. On every single iteration, we return the accumulator. So we start with an empty array. First iteration remains empty, we return it. Next iteration, we return, and so forth. So we start with an empty array and we end up with an empty array. Let me just comment this here so we see like a, okay. Now, if we want to do something with the accumulator and get back something different other than an empty array, we have to think about the condition. So on some condition, then manipulate the accumulator. So let's check the name. Remember, we have console log value, which is the user object. So let's say that we want to pick the element that has a name C, okay? And we want to put inside the accumulator array the value, the full value, only if the name is B. So I can say if value.name equals C, not B, and accumulator push value. So just put the whole object, right? So we go through the first object. The condition should be false because the value dot name is A, not C. And we end up like just returning the initial accumulator, which is an empty array. So this won't execute during the first execution, and accumulator remains an empty array. We go through the second object, then the value dot name is still not C. So this code is not going to be executed. So we return the accumulator that we received from the previous iteration, which is an empty array. Let me console log the accumulator as well. So we start with an empty. We have this value. We just return the accumulator. And on the next iteration, we picked up the empty array from the previous iteration. We have this value. We push, we don't push anything, we return. and the third iteration picks up still an empty array. The object now contains a name.c, value.name is equals to c. So this code will actually execute. So we're pushing into the accumulator the full value, the full object. And on the next iteration, the accumulator is not an empty array, as it was in this case. It's now an array with a single object, which is the third kind of like a user with name C. So now the accumulator is full of this like entry. The condition is going to be false, as the name is D now. So on the last and fourth iteration, we're just going to return the accumulator, which is now this object. So the whole thing ends, and we end up with the final array, which contains an object. Or of course, we can just push the name and end up with an array of names. And we can pretty much manipulate, like change this condition and say, if the value name is C or the value name is, let's say, D. So if either of these conditions are true, then just push something to the accumulator. And we end up with an array of C and D. So you can do whatever you want. You can check any conditions. You can create any condition in here, and then you can push any value to the accumulator. So you end up with a special function that reduces an initial array with a even more special array with a completely different form, right? So that's kind of like the power of reduce. You get an array which has a specific structure. In this case, it has these objects, and you end up with a completely different structure, an array with its much simpler string list, okay? So that's one kind of like a, or another variation of the previous reduce that's, you know, picking up some names. Let's use the reduce as a real accumulator, like something that, as the definition of the word reduce said, like pile up, you know, just put things on top of each other. So let's find the total, let's say, of ages, of user ages, okay? So we have, if you remember, 4 users, 20, 30, 40, and 50 years old. And if we add all of these values together, we'll get 140. So maybe this wasn't about age, this was about, let's add an amount. Let's say they have some money, okay? So let's also add amount. So we have 150, 150, and 0. So let's say we have these users, they're like, I don't know, bank customers or whatever. And we want to check to see whether, or get the total amount of points or money or whatever from our users. So we get like 150, 150 here, 300. Let's use the reducer to get all these amounts, pile them up, aggregate them, and give us the total. So here's how we're going to do this. Now, in this case, we start by input, output. So in this case, we're starting with an array, and we're ending up with a single value, which is a number, okay? So we're going to end up reducing an array into a number, okay? The value that we want to get is the total amount. So total amount. So first we think about it and say, okay, what's the output? It's a number. So users reduce, and now I'm going to start with the same like boilerplate. Okay, So, and a callback function with accumulator, value, index, and array, and the initial value. Now, I won't put an array here because what I want to accumulate and what I want to get back is basically 300, which is a number, okay? So I want the total amount to show me 300. So this is what I want this reduce. So I have to pick like an initial value. Now in this case, because we're aggregating numbers, it makes sense to start with 0, right? So think of like the simplest example. Let's say we had no users at all, or our users, none of our users had any like amount. What would be the proper value in that case? If you have no users and you asked for the total amount, you would expect to get like 0, right? Or if none of your users had like any amount, you would expect to see 0. So that's, I think, a value that makes sense as a starting number. So this is find the total of amounts. So we start with a number, which means that the accumulator that we should return on its iteration is going to be a number. So we start with 0, we return the accumulator every single time we run this function, and we end up with 0. Okay, so console log, you will see this 4 times. We start with 0, we return 0, we return 0, we return 0. We don't change the accumulator, right? So we end up with 0 at the end of this reduce function. Now, if I were to do something with the accumulator on every iteration, let's say that I added 1 to it. So we start with 0, okay, and then we add 1 to it. So in the next iteration, we actually return the accumulator, which is now 1. So we end up with 1 on the next iteration. We add 1, which becomes 2, we return it. So on the next iteration, the accumulator is 2. Add 1, 3, return 3, next iteration 3, add 1, 4, and so forth. So you can see here how we can aggregate, and we can do some pretty cool stuff by just starting with a number and then, you know, just doing some arithmetic operations and ending up with a different number. So that's one like case, but we don't want to just add 1, right? We want the accumulator to start from 0 and then accumulate the user's amount. So we're going to say the accumulator is equal, or we assign the value of the value that it already has plus the amount. So every time we take the accumulator value and add the amount of the user. And in this case, we are accumulating the amount. So let's see. So we start with 0, we have 100. So we add 100 to the accumulator, we return it, and on the next iteration, the accumulator has 100. The value, the amount is 50, we add 50, so we end up with 150, and we return 150. We have the amount is also 150 in this third user. We add them together, we end up with 300, and on the next iteration, the value is 0. We still add them, right? In here, this would be 300 plus 0. So we end up with 300, we return it, and at the end of this reduce life cycle, we end up with 300. So we used reduce to aggregate and pile up these numeric values. In this case, it's the amount. We could have just accumulated the aids. So in this case, the total is 140. We have 20, 30, 40, and 50, and we end up with 140. So we can get something like this. And we have our, let's say, total. So that's another cool aspect of the reduce function. We can use it as a function that kind of like piles up certain values, and we get a total. Now, let's see the other two values. Let me console log the index first, and let's see what we get. Now, the index will always be the same on every single invocation of the reduce function. Saying the index is basically the index, the array index, the position of the elements in the array. So if you remember, when you have an array with some elements, there's always an index for each value. Or if we have another array which has, I don't know, some other values, the first value is going to be at position 0, the second on position 2, and so forth. So this is the index. Okay. You iterate through an array, and every single iteration, you just start with 0 and you go 1, 2, 3, 4 up until the last element. Okay, which is always the length of the array minus 1. Okay, so the last index on any array is going to be the array length minus 1. The array length is 4, minus 1 is 3, so this coincides with the last element index. This array has a length of 3. 3 minus 1 gives us 2, so we can see that the last element is on position on index 2. So you have this index, and you'll see we can do some cool stuff with it later on. So the third argument, which is used not very often, but we can make use of it, has the position of each element. And the fourth argument of the reduce callback function is, as the name suggests, the full array, the original array, the users basically. I can use users here or R, and you can see here that on every iteration, this gives me the full list. So if for some reason I want to access the array users, I can either say users, or I can just use the fourth argument, the array. And you can see here that if I now put the length of the array, I will be getting the number of users inside the array. So array.length will give me 4. And since I have the index, and since the last index is always the array length minus 1, I can also check whether the iteration that I'm going through, the function call that I'm looking at, is the last one. Okay, so I can say if the index is equal to array length minus 1, so in our case, if index is 3, and it's going to be equal to the array length minus 1, okay, which means 3. So this is a check, a very simple check to see whether our code is at the end of the iteration. This is the last. So check if we are at the last iteration. And I'm going to say console log index value. Actually, double check that we can Okay, and you can see that it's only in the last iteration that we actually get to see the console log. Through this condition, we make sure that we are at the last function call. We're at index 3, which is the array length -1. So we can do something before moving on to end the reduce lifecycle and give back some final value. Okay. Now, when should you use like this check? When should we check whether we're on a particular position? Well, there are many options, there are many reasons why you might want to use this. One is that maybe you want to be reducing the values of accumulating, let's say, the amounts. And then in the last iteration, instead of returning a number, return something different. Maybe, I don't know, like return a string. So accumulate, and then at the last point, return something different. Or prepare maybe something that's even more, I don't know. So return the accumulator. Let's say total, something like this. So return an object. So start with a number, start adding the amounts to this number, and then when we're just about to return the last value to give back the last value that's going to be available to us, return something different, maybe more elaborate, maybe, I don't know, a little bit more complex. And then you can just return a final value that's going to be different from the initial value and from the value that we've been like changing on every single iteration. So that's like a very special case. I will comment this out because it requires extra care. You have to be very careful that you also like add to the accumulator value the last amount. So we have to add the value amount and then pick up something. But the index and the array are there to help you to see the current position of the element and also access the array and uh, do something according to the array length, or maybe, I don't know, even pick a specific value. So let's say that we want to find the max, the largest, let's say, aids number in the array. Okay, we go through every user and find the one that has like the largest number. So we start with list users, reduce, once again, the boilerplate, accumulator value index array. I return the accumulator. So this should be kind of like the first thing you do. And I have to think of the value that I'm going to start with. Now here's a tricky situation. In this case, I want to find the largest aids, which means the input is going to be an array and the output is going to be a number. Okay. So, or let's do this something different. Let's find the largest amount. Okay. We'll see why in a while. So we have like 50, 100, 150. Let's just console log just to make sure that we have, just to remind ourselves of the largest. So the largest amount right now is 150. So we want this reducer to go through its value, and I see 50, 150. Why? I should be seeing 4 values. Why am I seeing 1, 2, 3, 4? Yeah, and I see there's something wrong. I'm missing something. Maybe the open. Okay, A reduce. Okay, for some reason the array is missing a user. If I what did just happen? Filter users. Okay, that's strange. We're not seeing A here. Okay, yeah. Okay, this is interesting. I didn't expect this, but this is a lesson. Okay, I'm console logging the entries, and I'm not seeing the first entry. And why is this happening? Because I missed on the initial value. So if you don't supply an initial value, the reduce function thinks that you want to start with the second value onwards. It says, I will keep in mind that the initial value, since you didn't define it, is the first value in the array. So let me put the accumulator here. So let me start with 0. Okay. So we start with 0 and we get 0 every single time. You see 4 iterations here. Okay. So the initial value on the first iteration, the value still 0 on the second, and so forth. Or I can just add 1 to see something a little bit different. So I start with 0, I add 1, I return next iteration 1 plus 1, 2, next iteration 2 plus 1, and so forth. Okay. Now, what happens if I remove this one? Okay. The first thing you'll notice is that we see 3 iterations, not 4. Okay, we have 4 users, but we see 3 iterations. The other thing you see is this not a number. That's because we're trying to add 1 to the accumulator, which is this object. Okay. So let me remove this because it doesn't make sense. So what happens if we omit the initial value? The reducer will start for the second from the second element. So if we omit the initial accumulator value, the reducer will start from the second entry in the array. It says, I'm going to think of the first array element as the initial value, and then I will start counting from the second element onwards. Okay, let me just put the name here. So it picks up the first array element as the accumulator, as the initial value, which is an object that contains name, ID, age, amount. And then it starts from the second element. It doesn't start iterating from the first. It starts from index 1. Okay? Because if things things that we instructed it to consider the first entry as the initial value, and then start going through the second, third, fourth value. Okay, it's kind of like picks up from the second because there's no initial value. The first entry is considered the initial value, and we start iterating through the second. And now all we have to do is to think of a way to, do something with accumulator or the current value and return something. So if you omit the initial value, you're going to get the first entry as the default initial value. Okay, the accumulator is going to be the first entry, the full object. And then your reduce callback function will start from the second element. Okay, so that's something that we accidentally stumbled upon, but it's useful to know. Now, I'm going back to the initial idea, which was to find the largest amount. So what we need to do is we want to start with a value 0, and then start accumulating the amounts. So the accumulator will be the initial value plus the value dot amount. So we start with an initial value of 0, and then we console log max, and we accumulate and get a total of 300, which is it's correct. Okay. Now, we didn't want to, of course, to find the total. We want to find the largest amount. Okay. So now we get the max. I mean the total, but I want to get just one single number, which is 150. I want to get 150, not the total amount, but the user that has the biggest amount. So what can I do? So I will start with 0, and then on every iteration, the logic is the following: see whether the current amount is larger than the previous one that the accumulator had. So see if the current amount is larger than the previous one in accumulator. So we start with 0 and check whether we have something larger than that. And if that current amount is larger than the previous value, we want to switch to that amount. Okay. So in here, we start with 0. The current amount is 100. So I'm going to say if value amount is larger than accumulator, then return that amount. So instead of returning the accumulator, which initially was 0, I'm returning the current value, because that turns out to be larger than the previous amount. So we start with 0. The current value is 100. 100 is larger than 0. So I say, okay, return 100 instead of 0. So the next iteration, the accumulator, which basically the return value, I can also do it like this, if it's clearer. I just add and I return. So I start with 0, the value is larger than 0, so I return 100 instead. On the next iteration, the accumulator is 100. The current amount, which is 50, is not larger than the current accumulator value, so we end up discarding or disregarding this code and just return the current accumulator, which is 100. Okay, so the value is not larger than 100, so we move on. On the next value, we have 100, the accumulator. We have the current value, which is 150. We check to see whether the current value amount is larger than the accumulator. It is. So we end up replacing 100 with the current largest value. And we end up with the accumulator, and at the end, we get 150. During the last iteration, the accumulator so far is 150. The current amount is 0. It's not greater than the accumulator, so we just return the accumulator, and we end up with 150 in here. So this is a basic kind of like reduce lifecycle, where we go through its amounts and we do a simple check to see whether at every single point, at every single iteration, the current value, current amount is larger than the accumulator, compared with the previous value that we hold in memory, and we end up changing its value if it happens to be less than the current amount. This is how we end up with a reducer, a reduce function call that finds the largest amount. Now, the problem with this one is that it will turn out not to be working correctly if we have negative values. Okay, so let's see that I have in here, all these are negative like values. Let's see what we'll get. We'll get 0. Okay, but that shouldn't be, that isn't correct, right? Even amongst negative numbers, we still have kind of like a, or maybe let me put something like 50 here, 25. Right? Okay, so in here we have 0, but the largest amount, in this case, in the case of the negative numbers, is number 25, right? So if we consider negative numbers, if this also, maybe this amount is about temperature, right? So let's say we're trying to find the hottest temperature. So in this case, 0 would not be correct, because from these 4 entries, let's say the hottest temperature is minus 25. It's still quite cold, but comparing to minus 100, minus 50, and minus 150, we will have the wrong result if we get 0. So starting with 0 is not going to work with negative values, okay? We need something different. So let's see this case. I will move this. So in this case, I will create another list on users temperatures. And I'm going to say minus 100, minus 150, minus 50, minus 25. Okay. And now there's no amount, it's just a value. So it's just a simpler list. And users temps, let's see. Okay. So I iterate, and at the end of the cycle, I get 0 instead of like minus 25, which is the largest temperature, given that we have these negative numbers. So how can I fix this? Like, first of all, I start with a value that's not as low as I expected it to be, right? So 0 can be thought of as the starting point when we have like an age, right? So we don't have negative ages, so we can start with 0. But with something like temperatures, or maybe something that can be even larger than this, than the temperatures like in Fahrenheit or Celsius, we might have another kind of thing that goes down to minus 1 million or even more. So how can we end up by starting with like the lowest number possible, so that we end up comparing any negative number with like the smallest, let's say, possible number that we can compare it to. So I could come up with something, let's say in the temperature area, I would say, okay, is there like a minimum Fahrenheit number? Is there like a minus something that we cannot go below that? Maybe I would start with, let's say, minus 200. So we end up with a low enough value to compare with these values, and indeed we get like minus 25. Okay, but what if there's a value like this here, you know? let's say, let's do these 250. Yeah, let's get something like this, just to break the rule. Now we have the largest one, which is minus 500, and we end up with a wrong result. It should be minus 500, but we end up with this one. And this happens because we didn't have a low enough initial value, right? Minus 200 is like really, really much larger than the lowest one here. So we end up with a wrong result. So I say, okay, let's go down to 2000, minus 2000. We get the correct result. But then if I change these numbers and I make them above like this number, I'm going still to end up with a wrong result. So here's the trick. If you really want to start with the lowest number possible in JavaScript, you come up with minus infinity. Infinity. Okay. So in JavaScript, we have plus and minus infinity. So you have like the lowest number possible is minus infinity. That goes up to 0. And then you have plus infinity. So we have these two strange numbers. And you can use this. You can use them in the case of starting with the lowest negative number possible and then adding up or comparing. And if we want to go the other way around, to find the lowest number possible, we start with plus infinity, and we do the opposite check, and we can find like the lowest number in a list, right? So minus infinity and plus infinity are really useful in JavaScript, and we can use them in a case like this. Okay, so now no matter how big or large or low the values are here, we're still going to end up with a correct result, because any single value, any single negative value, that's of course not minus infinity, is going to be larger than minus infinity. So no matter the value here, your values are still going to be larger than the initial value. So you'll end up counting according to this decreasing order. So that's like I guess a relatively new thing that we've covered in JavaScript, the minus and plus infinity. Okay, let me give you one more example to just see how reduce is really powerful tool. So what I want to do here is find the unique values in a list. So let's say I have I don't know, letters. Yeah, let's stick with that. So I have this array, and I want to reduce it down to unique entries. So just single entry for every letter. So something like this. Okay, we have A, B, and C. That's the unique letters found in this array. So I want to go from this, reduce down to this, and we can do that with reducer. So I say unique letters equals to letters reduce. Okay, now the input is an array, the output is an array as well, right? So I'm going to start by saying that the initial value is going to be an empty array. That makes sense. If this array is empty, I want to end up with an empty array. Okay, either one or more letters. I will end up with an array that has one or more letters. So my initial value should be an empty array, and gradually I will be picking and putting some letters inside it. Okay, now the drill is the usual one. Fill in the 4 arguments and return the accumulator. And now we have to think about the logic. So think of this as the boilerplate, and this is the place where you have to think about what this reducer is going to do. So check if a letter is unique. Let's start by adding all letters unconditionally, okay? So we go through its value and we say accumulator push value. And I console log this. So we go through the array element, which are like 5 elements. For every single value, we push this to the accumulator. So starting with an empty array, we push A, then we push A, then we push B, then we push C, then we push B. Make sure to console log here the accumulator, the value, so that you see this whole process. Or let me just do it for you see how to start. Right, an empty array, the value, you push it. Next time the accumulator has A, you push A, you have A, you push B, blah, blah. So that's a nice way to X-ray your reducer. Of course, we end up not with unique letters, but with duplicate letters, basically the same array. So we have to do something here to make sure that we push to the array only if the value is not there, right? So if our array contains A at some point, we should not be adding A if it's already in there. So this means that this unconditional push should be put inside some conditional, and the condition is the letter in the array in accumulator already. So instead of pushing unconditionally, I'm going to first check whether the letter is already in the array. In this case, it's the accumulator, right? That's the temporary bucket. So since accumulator is an array, I can say if the accumulator does not include the value, so this checks whether the value is included in the accumulator. This negates this, which means it does not include the value in the array. And this is the only case where I include the value in the accumulator. Okay. So I start with an empty array. I check whether value A is included in the empty array. It is not included, so I push. Next time, the array has the letter A, value A. I'm checking whether value A is included in the accumulator. It is included, and then in the second iteration, you will see it is included. So this condition will be false, which means I'm going to disregard this and return the array as it is. Then move forward, check the value, check B, check C, check B, and we end up with the unique like letters. And this ends up being like a very simple, unique value separator in using the reducer, which is really nice. And also, I perhaps didn't mention this, but if you're not using a certain like argument, you can remove it. So I'm not using index, I'm not using the array, so I can remove it. But for now, I think for the beginning, it's nice to start with all 4 values. console log them, see whether you use them, you need them, and then remove them afterwards. But start with this basic boilerplate. So another cool feature of the reducer, which is basically filtering duplicate values, and also you can add something. You can manipulate the values, so you can turn them into lowercase. So you will end up with, oh, no, this won't work because I'm going to be taking lowercase with uppercase. So that's a challenge for you. Can we return a lowercase unique values array? So that's a challenge for you. Can we get something like A, B, C? So not only are we separating, are we removing duplicate entries, but we'll also end up with a modified version of the unique values, like a lowercase. Okay, so just an idea for you to play around and see whether you can accomplish this tiny challenge. So that's about the reduce function. We covered quite a lot of examples. I highly recommend that you look into reduce. It's really powerful and something that you will definitely be using a lot in as you progress and as you move forward and deal with all sorts of like arrays in your applications. Quick tip is, like, before you go into the reduce function, at least in production, make sure that there isn't already a method that does what you want to do, right? So there are other ways that we can take an array and get back an array with unique values. We don't have to use reduce. For playing around and for learning JavaScript, of course, it's nice that you use reduce to try a lot of things. But in production, first see whether there's a function already available in JavaScript for doing something like filtering or stuff like that. Okay, even though you can use reduce for basically doing anything you can think of with arrays. So as a practice, is really good, but in real life, when we, let's say, want to split an array or slice an array, and just get like a small portion, let's say, what if I wanted to get just these 3 elements? I would use array slice. I can do it with reduce, which is a great challenge and a great way to practice, but in real life, I just pick the tools that are already available for me, to me from the language.